All right, I know the way this is formatted makes it look like a YouTube short, but oh well, we'll try this and see what happens. So you do have all three of these blocks, and they're getting pulled by force F. And the first thing that we want to find is the magnitude of the overall force. We do know the force between B and C, and that is 3 newtons. So what we're going to do is we know that this tension in this string is pulling both B and A. So we're going to treat B and A as just one thing. So we're going to make that just one item all on its own. That means that this tension here, tension 2, is pulling the whole thing. And so what I did was first I said that 3 newtons is the force between B and C, and that is the same as tension number 2 right here. Then I said, well, I know to the right is going to be positive, so FT2 is positive, and that's what I wrote. And then FT1 is negative for B, but then FT1 is positive for A. So these actually cross off, and so you'll see that here. Those forces have to be equal to the mass of A plus the mass of B times A. So it's just the net force is equal to the total mass times the acceleration of that part of the system. The number for T2 we know is 3, and then each of the masses are 0.4, so that gives me an acceleration of 3.75. Now I can go back and say, okay, let's find the acceleration of the whole thing. So the acceleration of the whole thing is going to be all 3 masses times the acceleration. So that means that our net force is really just this guy right here, because we'll subtract FT2, add FT2, so those cancel. We'll subtract FT1 and add FT1, kind of like what we did here. So in the end, this really is just that force, that overall force. So I add all 3 together, multiply times that acceleration I just found, and I end up with 4.5 newtons, which is that correct answer. So how do we find the force on A? So that one, we're just going to find the force of tension, number 1, between the two, and we know that that is equal to just the mass of letter A times A, because that tension between A and B is really just pulling on A. Whereas the tension here was pulling on both B and A. And then the force here, which is the tension in this third string, is for everything. So we're just going to do just this little bit right here and worry about it. So now we're going to come down, and we see that FT1 is the only force going to the right. So that has to equal the mass of A times the acceleration, which we know is 3.75. So I just multiply the two together, and I get my answer. For the next question, you'll have to let me know if this one's right. If it's not right, send it to me again and I'll look at it again. But I'm pretty sure this is correct. I have these 2 blocks. They both are identical, so they have the same mass. I'm going to call bottom one A, top one B. And I know when I pull on A, just like when we pulled that piece of paper with your water bottle on top of it, they both move towards me because the force of friction is also pushing that towards me. So I know that the force of B, the net force on it, is equal to mB times A. Well, the force that's making it move, which is going to the right, is FF, so I wrote it first. There's nothing moving it to the left, and we're only worried about just B. We're not worried about A right now. So that force of friction is really just equal to the mass of B times A, because that's what's pulling B. When I put in that force of friction, remember force of friction is equal to mu S times the normal force, but our normal force is equal to mB times G, because that is the weight and they're equal and opposite. So when I plug all that in, notice my mB's cross off, and I'm left with mu sg is equal to the acceleration of that object. Well, if B accelerates like that, so should A. So now we can say the net force is equal to the total mass times A. We go ahead and put in MA plus MB for the total mass, and then mu sg for A, because that's what we said it was before. We add the two together, multiply times 0.35, then times 9.8, and I ended up with 9.604. So hopefully that is super helpful.